Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2238, indicates a low voltage condition in the air-fuel ratio AF sensor's input circuit. The AF sensor, sensor 1, is crucial for monitoring the air-fuel mixture entering the engine. It detects the oxygen level in the exhaust gases, allowing the engine control unit known as the Powertrain Control Module, PCM, to adjust the fuel injection and optimize combustion efficiency. When the voltage at the sensor's input terminal drops below a specified threshold, the PCM recognizes this abnormality and stores the DTC, which may subsequently illuminate the check engine light. It's important to troubleshoot this issue promptly to prevent potential engine performance problems and emissions violations. In this context, the air-fuel ratio AF sensor, sensor 1, plays a vital role in maintaining efficient engine performance and compliance with emissions standards. It is typically located in the exhaust system, mounted upstream of the catalytic converter. The AF sensor continuously sends voltage signals to the PCM, indicating the current air-fuel mixture. If the voltage at the sensor's input circuit drops too low, it hinders the PCM's ability to manage fuel delivery accurately, leading to inefficiencies in combustion. The PCM, acting as the engine's brain, relies on inputs from multiple sensors to make real-time adjustments for optimum performance. A failure in the input circuit can disrupt this vital feedback loop, negatively affecting engine behavior. Several factors could lead to the triggering of DTC P2238. Firstly, a short circuit in the AF sensor wiring may cause lower voltage readings. This can happen due to damaged wires that may be frayed or improperly connected. Secondly, the AF sensor itself could be faulty. If the sensor is unable to send accurate readings, it can lead to poor engine performance and the corresponding low voltage error. Lastly, if all other components are functioning as expected, the PCM may be at fault, failing to interpret sensor data correctly. Each of these causes will need to be thoroughly inspected to determine the true source of the problem. Symptoms associated with DTC P2238 include the illumination of the check engine light on the dashboard, indicating a need for immediate attention. Drivers may also experience poor engine performance, characterized by sluggish acceleration or rough idling, as the engine struggles to maintain the correct air-fuel mixture. Additionally, there may be a noticeable increase in emissions, which can lead to failing emissions tests. It's crucial to address these symptoms promptly, as they not only impact vehicle performance, but can also result in further complications, including damage to the catalytic converter if left unchecked. The first step in troubleshooting DTC P2238 is to inspect the external circuit connected to the AF sensor, sensor 1. Begin by checking for any visible signs of damage or wear in the wiring harness. Focus on areas where the wires may rub against components or where there could be tight bends. Next, carefully inspect the connectors to ensure they are securely fastened and free of corrosion or debris. Proper electrical connections are critical, as any loose or corroded connection can lead to erroneous voltage readings. Utilizing a multimeter to measure continuity may assist in identifying short circuits and verifying that the circuit operates within the specified parameters. For the second troubleshooting step, the AF sensor, sensor 1, itself must be inspected. Since there's no direct method to check the sensor's operational status, the procedure involves replacing it with a known good component. This process helps confirm whether the existing sensor is faulty. After installation, road testing is necessary to see if the DTC reappears or symptoms persist. If the failure is reproduced with the known good sensor, this indicates that the issue lies elsewhere in the system, potentially related to wiring or the PCM. However, if the installation resolves the issue, the original sensor is confirmed to be defective. The final troubleshooting step focuses on the PCM itself. If the previous inspections indicated that both the wiring and the A-factor sensor are functioning correctly, the PCM may be the remaining suspect. To confirm this, check for any other potential faults in the vehicle system that may have gone unnoticed. If those are all ruled out, then it's likely that the PCM is malfunctioning. Replacement of the PCM should be performed only if there is sufficient evidence that it is not responding correctly to the input from other components. It is important to note that PCM replacement involves programming and calibration, ensuring it syncs appropriately with the vehicle system. After completing repairs associated with DTC P2238, it is crucial to verify the effectiveness of the repair. Begin by resetting the PCM, which can often be accomplished through an OBD-II scanner. Once reset, start the engine and hold the engine speed at 3,000 RPM under no load to allow the PCM to recalibrate based on the new inputs from the AF sensor. After performing this operation, allow the engine to idle and closely monitor any DTC that may reappear. This verification step ensures all repairs are effective and addresses the initial issues indicated by the DTC, confirming proper engine function moving forward. To prevent issues related to DTC P2238 from occurring in the future, regular maintenance and checks should be performed on the AF sensor and associated wiring. Conduct inspections of the wiring harness yearly, particularly in areas exposed to heat, friction, or moisture, as these conditions can lead to premature wear. It's also advisable to monitor the performance of the AF sensor routinely, using diagnostic tools to ensure it operates within the specified ranges. Early detection of potential problems can help in making timely repairs, maintaining engine efficiency, and avoiding costly repairs down the line. In conclusion, DTC P238 signifies a low voltage condition in the input circuit of the AF sensor, Sensor 1, which is vital for optimal engine performance and emissions control. Proper troubleshooting should approach the issue systematically, beginning with external circuit checks, moving to the AF sensor itself, and ultimately examining the PCM. Each step taken should be meticulous, as skipping any part of the process could lead to misdiagnosis. Additionally, implementing preventive maintenance is crucial in extending the lifespan and functionality of the components involved. Adhering to these practices will not only ensure vehicle safety, but will also support efficiency in fuel usage and compliance with environmental regulations. Please like and subscribe to the channel. See you next time.